Hello, everyone, and I welcome you today for this webinar. And I appreciate your presence and patience too. And I'm Puneet Joshi, and it's my privilege to represent Math Revolution. Today, we'll be talking about one of the most crucial topic that GMAT Math has. But before going ahead with it, I just want to tell you something about Math Revolution. I'll be talking a lot on the quant part, majorly in the breaks of the session that we have today. So I again welcome to everyone who has joined us right now, and also expecting more people to be a part of this to make it a great success for us. GMAT, if I'm not wrong, GMAT math actually tests you on your concepts. It does not require you to solve into the conventional methods. It does not require you to go ahead and write down the solutions on the paper. It's just winning over time and strengthening your basic concept, and therein where you progress and perform from 600 level questions to 700 level questions or more. I agree to the fact that verbal also plays a very important role. Yes, but again, if you're able to manage, I mean, you being a GMAT student would always have a possible combinations into your mind that what your future colleges and universities are looking forward to. So it's like if it's like 700, 730 plus, you should be very well acquainted with the possible combinations that if I being a student today, if I can manage to score Q47, what will be my verbal score? But as per my experience teaching over 1,200, 1,500 students across the globe, I would say quant always have the upper edge than the verbal. And it's proven. I mean, like it's become very easy for you to crack the quant part. And then again, you can definitely go ahead and perform well with your verbal. So I'll be talking a lot of uh, talk about the math revolution, what we do, and but let's start with it. What is our today's content? How can you master time, speed, distance, and work rate problems? Now, there is a special word that I have into it here, and that is master. How do you master it? This is the important word. How do you master it? So I don't doubt on the potential and the capabilities of all the students who are a part of today's webinar, and also who would be, looking at it in the future times. I know that you know the concept of time, speed, and distance very well, but how do you master it is a different. How are you an expert into this? When I say an expert, what I mean exactly is how do you well comprehend the question? How well you connect the information, and therein where how well you manage within the time limit to solve the questions. Now, GMAT, again, we know is being well categorized as problem solving, that is PS, and data sufficiency, which is DS. DS is scary, yes, and but it's not so scary because today I'll be introducing you one of the fantastic, proven, and systematically designed technique to demystify the DS questions. Uh, the time is the limit, so I won't be able to talk much about the depth of that particular approach. But yes, I'll show you certain applications, and therein where you can definitely go ahead with it. And I myself has been looking to the chat window. So, if you have any questions, if you have solutions to the questions, you can definitely shoot, and I'll try managing the answer to a couple of those maybe, right, without losing the track of the topic. So when it comes to time, speed, and distance, or work rate problems, or average, total, and sum, there are the three variables, it's three variables linked with each other. Now, how a GMAT student is different from any other student, an expert of a GMAT quant would be different than any other student in the sense that he or she does only not know that speed is equals to distance over time, but at the same moment, at the back of the mind, they're well prepared with the fact that speed multiplied by times is distance. So they don't have to write it. It's there in the back of their mind. Distance is equals to speed over, you know, speed over time. And this is distance is equals to speed times time. If you need to find the time, it's distance over speed. They understand that speed and time is inversely proportional to each other. So they don't have to derive the expression every time from one single expression. It's already prepared with them. So when they comprehend the question, they know what has to be found, and then they directly put the values to get the answers. So let's go ahead with this. Let's talk about the first thing is speed and rates, speed and mileage. GMAT would often encounter certain units like miles per hour and currency in dollars, pounds, yes. So speed, if denoted as V, distance is D, and time taken as T, that is very basic. We know speed is equals to distance over time. We can keep those values as V equals to D over T. But at the same time, we should understand that V times T is equals to D. Now, let me mark you on this. This particular equation is something I want you to remember from today rather than this, because this is something which you have already learned during your high school physics and math even. But Vt equals to D, this is one of the equation that I want you to keep ready always when you are encountering such kind of questions. If we go ahead with this just for the sake of an example, so try solving the questions all together in just say maybe 2 seconds. Car A can travel 120 miles in 3 hours. Understand what is given, what has to be asked. 120 miles. It travels 120 miles. That means the distance has been traveled, time in 3 hours. What does that mean? So you need to find just one unknown quantity, and that is speed. Now, this is a very simple example. And then in where the application of formula comes into picture, that is the speed equals to distance over time. That happens to be 120 miles over 3 hours, which becomes 40 miles an hour. 40 miles an hour, 40 miles per hour, both sounds okay until it is into the same kind of units. Let's go with the mileage. So mileage has been denoted as m, distance is d, and the gas that is being used is denoted as g. How do you relate this? So you relate it into the same form. So mileage happens to be distance over gasoline. You can definitely make a note of this particular logic that mg is equals to d and m is equals to distance over gasoline. And therein where you can definitely make a mark out of it. So it's as same as the speed is equals to distance over time, average is equals to sum over total. So again, the three variables, I repeat myself, three variables interlinked. There should be three expressions and it should be well prepared so that you can directly apply what is required. Basic questions again, the car C can travel 250 miles. That's the distance with 10 gallons of gas. So in 1 gallon, definitely it will be able to travel 25 miles. So that's a 250 over 10, 1 gallon, 25 miles. Now, if I ask, so suppose if I have 20 gallons of gas, how many miles does that particular car can travel? So now when you have G with you, it's only the distance that you need to travel, and that is wherein you need the speed. So speed is in 1 gallon. If it can travel 25 miles, in 20 gallons it will travel 25 times 20, and that happens to be a distance of 500. So this is wherein absolutely Alok, that's 500. So see, this is wherein you are different than the conventional solving, right? Let's move ahead with it. Okay, importance of units. So why does it is very important for us to deal with units? So I mean, like, when we talk about equations, when we talk about fractions, when we talk about some other, any topics, geometry or maybe something, geometry doesn't include units. A unit plays a very, very important role over here. But one thing that you would also agree with me here is distance is always expressed in a single unit. That is, it could be kilometers, it could be miles, it could be meters. Time, on the other hand, would always be expressed in terms of hours, maybe minutes. Minutes is very rarely seen, seconds is one. Speed is a very well combination of distance and time. So it's miles per hour. There are two terms which you could see. I have come across many students who are actually facing trouble in understanding and comprehending from the question that which particular variable is given into the question. Is that the distance? Is that the speed? Or is it, the time? So basic is just look at the units. If it is a single unit, it has to be a terms of miles or kilometers. It has to be a distance. If it is, an hour or a second, it has to be a time. If it's a combination of both, kilometers per hour, miles per hour, meter per second, then it has to be a speed. And therein where you're already and set to go. So units are important and should be changed as needed, as we have been talking about it. So we can change the numerator or denominator depending upon the situation. So now see, the distance, if it is given in miles, but time is given into seconds, I have to change that into hours. Now, the concept that comes here into the picture is not of speed rate. Okay, you have already applied the concept of speed equals to distance over time. Now you are applying a second concept, which is how is hour and seconds related. So that is like we know that 1 hour is 3600 seconds. So therein where this particular concept, the unit conversion, comes into the picture. Now, if you are not that good with all such kind of conversions, then a student often says, what, a speed distance time is very difficult. No, a speed distance time is not a difficult topic. You already know the logic that the speed is equals to distance over time. It's the conversion that is creating a problem for you. So you could practice such kind of conversions online many a times, or you can see those onto our websites as well. Now let's put up the first question. A motor vehicle traveling at a certain constant speed takes 10 seconds shorter. Now see, there's a vehicle which is traveling, but it is traveling at a certain constant speed. It is taking 10 seconds shorter. So when I say it is taking 10 seconds shorter, that means at the back of my mind, it should be there that if it would have traveled at certain speed for a certain amount of distance, it would have reached 10 seconds before it. And therein where they're comparing it with 10 seconds shorter. When you say comparison, there happens to be a ratio or a proportion kind of thing. So it says it takes 10 seconds shorter to travel 1 mile. So what is the distance that they are talking here? 1 mile. What is the time they are talking here? There's no specific value for time given here. It's a difference between the time, and that is 10 seconds. 1 mile, then it would take to travel 1 mile at 60 miles per hour. So if that particular motor vehicle is traveling at 60 miles per hour, so that's the speed, for a distance of 1 mile, whatever time does it take would be 10 seconds shorter to travel 1 mile. And what is the vehicle's speed in miles per hour? Question is directly asking you about the miles per hour. That's the speed. Your options again say 65 mph, 68, 70, 72, and 75 mph. Again, that's into the same units. So what could be the approach for this? And before going ahead to solve this particular question, I would say, why did I break that particular question? Why didn't I just read it out? Because I don't want you to read that out all in one go. It's a very basic fundamental that when you come across such kind of questions, especially the word problems that you'll deal into GMAT, you need to break that. Stop yourself at the point where you get the data or the information, write it down, try to relate it, then move ahead. At the end of the question, you will definitely know what all informations have been provided to you, what has to be found out, and the best way is with the given information or the collected information, you can definitely relate what has to be found. So if we go ahead with this particular solution, I'm still waiting for someone who could have tried solving this particular question right now and could have given me the answer over the chat. But again, let's go ahead with it and let's try questions. So see, we say units are important. Okay, Avin Gupta has told me 72. Okay, let's see, Avin. I believe that is a correct answer, but let's go ahead with it quickly. So units are important and should be changed as needed. Solving questions of speed. We don't require much unit here, do we? So it doesn't look to us, but again, if you see, indeed, this is per hour and this is seconds. So this is a catch, and therein where I say, whenever you get the data, stop yourself and write it properly. 10 seconds, 1 mile. So again, the question is, answer is required in miles and seconds. The speed is given in miles per hour. So that is wherein, let's talk about it. Speed is 60 miles per hour. Time is 1 hour. Let's convert that into seconds. Because if I have to take 10 seconds less, I need to know how many seconds that 60 miles per hour was traveled. So again, 1 hour would have 3,600 seconds. So the basic ratio that I get here for distance to time is 60 miles here is being covered. 60 miles is covered into 3,600 seconds. That means 1 mile is covered into 60 seconds. So this is the information that we have got from this particular place. So 1 mile was traveled into 60 miles per hour. So 1 mile actually takes 60 seconds. Now, 10 seconds shorter to travel. That means if it was travel into 60, definitely 60 minus 10 would be 1 mile equals to. So 1 mile is to 50 seconds. This is the ratio that we have right now for the miles and seconds. If we go ahead with this. Now, what is the vehicle's speed in miles per hour? This has been conventional from a long time. Anything unknown, take it as X. So, suppose the speed is X miles per hour. So I need to travel it for an hour. So I take it as X miles per hour that relates to X miles for 3,600 seconds. I already know that X is to 3,600 seconds would be rated to 1 is to 50. So this is X miles per hour. This is 1 miles. This is 3,600 seconds. That's a time. That is 50. Now see, the distance is same. So this is how they have related here. And then if you just go with the property of a ratio, A is to B as C is to D. So we know this. After the cross multiplication, we could get AD equals to BC. Okay, 72. Yep. So Aveen and Vinayak is correct on this. So 72 miles per hour is the correct answer for this particular question. Fine, let's go ahead with the another question set and another concept. Speed into time equals to distance. I won't take much time on this particular. This is a very basic concept. It's speed into time equals to distance. And speed equals distance over time. Time equals distance over speed. So that is pretty okay. Let's go with the question now. Car A drove 270 miles. Distance is given for car A for 4.5 hours. Time is given. What is left? Speed. The speed is left. You can find the speed of this particular car just by dividing 270 by 4.5. Your two data give you the third unknown data. You're ready. The other car B, okay, also drove the same route at a constant speed, that is 10 miles per hour, less than the car's A speed. Car B is driving the same route at the 10 miles per hour, less than what A has driven. So again, understand, I do require the speed of car A. If I could manage to get the speed of car A, minus 10 miles can give me the speed of car B. How many hours did car B take to drive the same route? And then once I get the speed, I have to find the time also. So that particular time can only be found by, very good. So speed of car A is 60 miles per hour. Okay. So if the speed of car is 60 miles per hour, one of our gentlemen has already given us the answer for this. If the speed of a car is 60 miles per hour, then the speed of car B should be 60 minus 10, that is 50. And 270, that is a distance divided by 50. So see, the answers have started coming. Let's go ahead with this now. So you can always relate it to the ratios, like X miles is to 1 hour is equals to 270. Perfect, guys. Perfect. 5.4, 270 over 4.5 equals 60. Distance is 60 miles. That happens to be 50. 270, 5.4. Bingo. Perfect. Awesome. Let's go with another one. The same amount of time has passed. Now this is a bit tricky thing, the same amount of time has passed. What happens in this scenario particularly? There could be two people traveling. There could be one person starting the journey and another following the same journey, maybe after like half an hour, maybe some minutes, or maybe an hour or two, and therein where we need to see. I recall such kind of questions during my school days when I used to solve such math questions. There used to be a question that, so there used to be this thief, and the police used to see this particular thief from a very long distance. And once thief, infers that the police has already seen him, he starts running. Now, that particular distance, he is already far from police has to cover that distance first, but meanwhile the thief will not stop, he'll keep on running. So this is the logic that you need to develop for such kind of questions. So we'll just go with the basic. What does it say? The question is related to two cars. If question is related to two cars, very specifically two cars, a person meeting each other, it will be related to same amount of time. Now, what does this mean exactly is I can only show you with the application of the particular question. It says John traveled westward past a certain bus stop at a constant speed of 40 miles per hour at 12 p.m. So the journey started at 12 with a speed of 40 miles per hour. 10 minutes later, Tom passed the same bus stop. So at 12 and 12:10 are the two moments when the journey is started. Tom passed the same bus stop westward at a constant speed of 50 miles per hour. Perfect. So we have been given with the speed of John and Tom both, that is 40 and 50 respectively. The journey started at 12 and 12:10. Now this 10 minutes of difference will be the major catch, and all the calculations would come around it so that we can get to the answer. If both travel at their constant rate, so they're not changing their speed, at what time after John passes the bus stop will Tom catch up with John? Now, see, always pay attention to this particular line as well, because many a times the GMAT plays on this kind of information. At what time after John passes the bus stop? At what time after Tom passes will catch up John? So there would be certain, tweaking of the words, so play around with the words, and you can make answer mistakes. So just pay attention to this. So again, the I'll go ahead with this. So what you need to basically understand is that John has started at 12 p.m. and Tom has started at 10 minutes later. Now that particular 10 minutes, and see again, the unit plays a very important role. 10 minutes is 1 over 6 hours, right? 10 divided by 60, that is how we convert it. So that is 1 over 6 hours. Now, in that particular 10 minutes, when Tom has not started the journey, John is already traveling at a speed of 40. So try to find out the distance that he would travel during that particular 10 minutes. So it's very simple. It would be 40 into 1 times 40 into 1 over 6. That is 40 is the speed, and 1 over 6 is the time, so you multiply because we have already divided 10 by 60, so that's 1 over 6. So distance happens to be 20 over 3 miles. Okay, so people are already ready with their answers now. All right, so now I want you to see this particular diagram at least for 20 seconds, and then I'll start again talking about the same, the what actually we have done. So what we did here is, this is the point therein where we expect them to Tom catching up with John. Now, Tom catching up with John is Tom's journey is not broken into any sort of things. Is starting with 50. That's his speed. T is the miles. That is, suppose after T time if they're expecting to meet. So this is something, the distance that we have got. Now, John's journey has been divided into two parts. So for first 10 minutes, if we say from here to here, it's like 20 over 3 miles distance and then 40 miles distance. So now this particular distance has to be same, and therein where we'll put. I'll again repeat the same concept. Tom's journey starts from a point, and they catch up 50 t miles, wherein but John has 10 minutes journey at the start and then the remaining journey. The speed is constant is 40, so the distance that he would travel would be 40 times t plus 20 times 3, and this should be equals to 50 times t. If the distance can be put equal, then we're done. Once we solve this particular equation that I said, that is 20 over 3 plus 40t is equals to 50 times t. Solving for t get me a value 2 over 3. Now, what is the question? At what time after John passes the bus Tom will Tom catch up the John? 2 over 3 hours. We are dealing into minutes. Hours converted to minutes, multiply by 60, you get 40 minutes. Now, either the answer happens to be 1240, either the answer happens to be 1250. And this is what I said. You need to be very, very focused on this, because both the option is something that I can see here. One is B, another is C. 12 is the time, 40 is your answer. So you have solved the question 99%. Now, if you mark it 1240, then the comprehension was the problem. It was never the speed distance concept. So just be focused. And let me tell you, it may happen with even a very brighter students also. So just be focused and just be confident about what you read, you understand, and therein where you go with it. Round trips. So I go to office and come back from the office. My distance remains same until I take some another route. And so if I'm experiencing the traffic or maybe a jam, then definitely the time that I'll take would be increased as compared to the return journey, wherein it was the open road for me and I could have easily managed to come through. So in this scenario, if it's a round trip, it's a place and return from the starting point. Let's go ahead with the question set. It says, an ambulance take a 20-mile trip from the hospital to an emergency site at a constant speed of 60 miles per hour. So first journey is from hospital to emergency site. So there would be the speed, there would be a distance, there would be time. If the ambulance uses the same route back to hospital, now the route is same, but again the direction is changed. So we assume it to be speed 2, distance 2, and time 2. So if we notify it V2, T2, and T2, this is how we can notify it. It will take 50 minutes for the round trip. So overall round trip is for 50 minutes. That happens to be T1 plus T2 equals to 50. Perfect. Are we be given the value for V1, that's the speed, 60 miles per hour. Great. Do we have the values for distance? 20 miles. Okay. So V2 is still unknown. And what is the average speed of the ambulance while coming back in miles per hour? See, the answer is already there, because this is wherein you relate it. So V1 is 60 miles per hour, the distance is 20. So your time happens to be 1 over 3, which is 20 minutes. If going from hospital to emergency is taking you 20 minutes time, definitely the overall round trip, when it says is a 50 minutes, then the return journey happens to be only 50 minus 20. That happens to be only 30 minutes. Now you have a time, you have a speed. Do you have a speed? No, but you have a distance of 20 miles. Therein where you can definitely solve it. But just pay attention to the fact that it is in minutes. It's rarely seen, but again, this has to be converted into hours, and therein where 20 miles distance divided by the time of 30 minutes converted into hours will give you 40 minutes, 40 miles per hour. There's the answer for A. Perfect. Okay, so we have a concept of average speed, and I've seen a couple of questions on GMAT about the same. Average speed plays a very important role. There would be a lot of questions that average speed has. It's just a total distance over total time. And if you could sense that the distance is same and it's a constant, then speed is inversely proportional to time, and therein where you can definitely apply the logic of harmonic progression or harmonic mean. and you can find the values of the speed. So we'll solve one of the PS questions. It says in traveling 100 miles, we travel at 40 miles per hour for the first 50 miles and travel at 60 miles per hour for the last 50 miles. Now see, the complete distance is 100, therein where this particular 100 miles is already been divided into 50 miles and 50 miles. And then you have 40 miles distance for first 50 and 60 miles of speed for the second. You need to just find the average speed. This should not be a very difficult question for you. You can definitely go ahead and find the time one for the first journey by dividing 50 over 40 from here, because 50 miles per hour, 50 is the distance, 40 is the speed, 5 over 4 is your time. Secondly, again the 50 is your distance and 60 is your speed, divided 5 over 6. Now you can add up both 5 over 4 plus 5 over 6 to get the total time. Once you get the total time, your total distance is of 100 miles. Total distance over total time will give you this average speed of 48 miles per hour. Now see, this is wherein you play very smart. For this particular expression, I would like to highlight. Why? Because 4 plus 4 and 6, the LCM would be 12. But what I know this, that I have to divide this time. So I have to use this time dividing the distance which is in 100. And dividing by 50 would have be more easier for me. So simply just cross multiply 6 times 5, 5 times 4, 50 over 24. 24 goes up and I get this expression very easily. This is just a, I would say your presence of mind. Even if you go with 12, your answer would be same. So presence of mind again plays a very important role during such kind of exams. Yes. Now, this is something, this particular, you know, webinar is being taken by me because data sufficiency is a kind of question therein where you've been given two conditions. There's a long question or maybe a short question. Sometimes they ask about an open-ended question, is x greater than 0? Sometimes they ask about a unique value question, find the value of x. You're being always sufficed with two types of conditions, and therein where you need to actually find out, relate. I've seen majorly what a student does is they often run chasing to find the answers. So data sufficiency is not at all asking you to find the answers. They want you to just tell whether data is sufficient to answer the question. So this is the first difference that you should know. I'll be talking about one of the approach that has been designed and first time in the world. You can see about it in the detail on our website, which is www.mathrevolution.com. You can visit, you can register, you can see a lot of lessons onto it. You categorize the lessons as per the topic and as per the question types like DS and PS. But DS, especially for a variable approach that I'll be talking about today, and its application is the major key. And this is wherein, if you have a lot of questions to it, you can simply shoot an email to us, and I'll be one of the person to definitely answer those. You can drop us an email at info@mathrevolution.com. You will get all this information onto our website, so you could definitely get through it. So DS questions, let's say the speed rate of one person. Now see, the concept again remains the same. That's a speed rate. Vt equals to d. That's okay. So Vt equals to d again. How many variables are we dealing here? Three. Speed, that is v. Time, that is t. Distance, this is d. And there is one equation which is already related, Vt equals to d, in the original condition. So even if they talk about the speed, distance, time, that's been known that they are related to each other. Now, when I have three variables here, if you see here, I have three variables and I have one equation. So variable approach says try matching the number of variables with the equation. So many a times in the question, you won't even get equation also. So therein where, I'm asking you to just visit our website to get to know more about the variable approach. And once you are expert into it, I'm telling it to you, you'll be able to solve the DS questions very quickly. All right, so three variables, one equation. So three variables should have three equations to get solved. So three variables, one equation. I need two more equations now. Now, where does this two more equation comes from? So this will come from the condition one and condition two. If it can, definitely my answer would be C. This is why we have used it has to be most likely correct answer. We'll see the application of this particular logic here in the question. What was the distance John traveled in miles? The question is asking only about one thing, and that is distance, D, that John has traveled. Now, there is a condition given to it, which is John can travel at a constant speed. I don't want to read the conditions first. That's okay. I just want to understand John travels a distance in miles, and that is what question is asking. I'll simply apply my variable approach. I'll just see. I need to find the value of D because I know that the distance is already related with the speed and time, and speed is equals to distance over time, or speed into time is equals to distance. So I'll need the value of D here. So that is one. Secondly, I have three variables already with me. So now this is the beauty of this particular approach. If it's a speed distance time question, you already know that there are three variables to it, Vt and D. There would always be one equation you can talk about, Vt equals to D. So now, are you able to get two more equations from two different conditions? If that works, your job is done. So now let's go. How do we go ahead with it? Recall three principles. Now for these three principles today, I may not have much time to talk about these three principles, but again, these are such sort of principles that has been, designed in such a way that in where you can definitely choose the answer or you can jump to the answer. Now see, why am I not considering equation one separately or condition two separately to solve to see whether single situation or condition works for me. If not, then I'll combine them. Why am I directly taking condition one and condition two together? Because this is the what variable approach helps me to do. It has already told me that there are three variables and one equation in the question. You are more likely to get the two equations from the condition one and two. Why do you have to go for condition one and two? Just solve the question directly taking the condition one and two together. So I'll just go ahead and solve the question with taking a condition one and two together. Condition one says John can travel at a constant speed rate of 60 miles per hour. Good job. 60. So one thing I got here is 60 miles per hour is already I have here with me right now. That's a speed, right? My job is still not done because for the distance I need one more variable, and that is a time. John took 2 hours to travel the distance and had a 30-minute break. Now see, doesn't matter if I travel a distance for 5 hours, but if I'm continuously traveling for those 5 hours, then the time consumption would be taken as 5 hours. But again, over here, it says 2 hours, but with a break of 30 minutes. That means I've just traveled for 1.5 hours. More precisely, I can write it into a fraction that is 3 over 2. And this is 3 over 2. And so if you have a time 3 over 2, if you have a speed, your job is done. You can find the distance, which is done. So 60 was a speed, 3 over 2 is a time, 90 is a distance. Unique answer because in GMAT, if I ask you that is x greater than y, so many a times x can be or y can, it may not be, not necessarily. You need a unique answer. If there happens to be a unique answer, then it is what we call it as sufficient CMT2. Now, see, these are not jargons, but these are actually CMT stands for common method types. So we have got 4 different common method types. This is all we cater to the students when they are actually onto the lessons they go through us. So they learn the CMT, they learn the variable approaches, and they're very much familiar with this particular, the red CMTs and the names of approaches. I understand for you it may sound a jargon right now, but you can definitely check those onto our website for sure. So let's go ahead with this. So unique answer because condition one and condition two combined. So my answer would be C. The job is done. I don't have to check condition one separately. Okay, fine. Let's check it for a while. Condition 1 says John can travel at a constant speed rate of 60 miles per hour. Okay, fine. So now I've only got a speed of 60 miles per hour. Then how can I say what is the distance? Right. I cannot say the distance because his journey in miles, I can in 1 hour if he's traveling 60 miles. I don't know how for how much hours he has traveled, right? So I don't have a value for time. So condition one is not sufficient. If I say that condition one is not sufficient, my answer A goes out, and at the same moment D also goes out. Now I join back to B. John took 2 hours to travel the distance and had a 30 minutes break. Now, therein where a student does a mistake, while talking about or considering the equation 2, at the back of their mind, they start thinking about condition 1 also. So why? You just, when you think about condition 2, it has to be just condition number 2. So take a condition separately, one at a time as a single. Don't mix until you are actually combining them to answer. So John took 2 hours to travel the distance and had a 30-minute break. No, so because the speed is not given, so it doesn't matter how what is my speed traveling for those 1.5 hours. So at the end, if our first equation is giving me speed, a second equation is uh, time, the distance is, we all know now distance is equals to V into T. Your job is done. And this is why variable approach helped me to take condition 1 and condition 2 right together at the start, rather than wasting my time or ours time indeed as a team in first eloping that condition 1 and 2 cannot work together. So this is the beauty of this particular variable approach. Yeah, it's tricky at times in certain questions, but again, the concern is, uh, you know, you need to master it. And once you master it, it would be great for you. The speed rates of two people. Now let's quickly go ahead with it. Let's put into our mind. For one person, we had V, we had T, we had D, we had one equation VT equals to D. For two people, we'll have V1, V2, we'll have T1, T2, we'll have D1, D2, and we'll have two equations respectively for them. So in total, we have six variables. We have two equations. So how many equations do we require more to solve it now according to the variable approach? We have six variables. We have two equations ready. We need four more equations. Now, where does this four equation comes from? I don't get four conditions, right? I don't get four conditions into my DS. I just get two conditions. So the most likely answer could be E. So in that particular scenario, even the slide would talk the same, which I've spoken right now. So E should be the most likely answer. Now, let's talk about a question. John has planned a vacation. Okay. He estimated the distance of the trip and his average speed. Okay. So he has estimated something, that is the distance of the trip and his average speed. If he calculated the estimated time, then what is the difference between the estimated time and the actual time for the trip? Now, see, I do understand that, the slide before it has talked about two people, and therein where we were easily able to catch the fact that, two people, so they have their respective speeds, distance, and time, and two equations. But again, pay attention to the words estimated and actual. They themselves has a difference. And there is where the question justifies what is the difference between. So now what you can do best here is you can estimate. So you can assume that the estimated time is T1, estimated distance is D1, estimated speed is V1. And the actual time that has been taken by John during his vacation that he planned was V1, V2, T2, and D2. So now you ultimately have got six variables. You've got two equations ready with you. You need four equations. That is something impossible to get out of two equations. That's again speed questions too. This is how we have gone through right now. This is what it shows us. The most likely answer should be E. Now, if I'm saying that the most likely answer is E, so if D would have been my answer, then A would have definitely, or B would have definitely separately worked, right? But why am I telling E as my answer? That E and C happens to be the last option that you should check upon. I repeat, if A becomes your answer, when you check the first condition, and if that is sufficient enough to answer the question, then your answer could be A or D. Then you check the B as a separate. If B doesn't suffice, then your A is answer. If B suffices, then D is your answer. So this is wherein we have been always trained with the GMAT DS options, because they never changes and they haven't changed in the history even. But now when you have decided that E could be the most possible answer, that means you yourself is answering it that neither A nor B, even combined, can answer this question. So much better is to see the combination of both rather than, first of all, solving the first and the second equation separately, then coming back to the combination. Let's solve condition one and condition two together. Condition one says it took 2 hours for him to actually go on the trip. Actual time is given. Oh, okay. What about the other variables then? I don't have other variables here. Sorry. Let's go with the condition two. John estimated his average speed to be 20 miles per hour. Let's combine both. His speed is 20 miles per hour, and it took 2 hours for him to actually go on the trip. So you have V1 that is 20. You have T2 equals to 2. What about the other variables? You cannot get the values for D1s and D2s. And in this scenario, you cannot determine the unique values of. So you have values of T2 here. If you can manage to get value of T1, definitely you can find the difference between both the estimated time and the actual time. One of the equation gives me T2's value, but T1 cannot be found from here as this is a single variable V1 equals to 20. So my job is still not complete. So ultimately, this will be not sufficient as I'm not able to answer even with the combination, and the answer goes as E. Four variables and two equations. We will have four variable, and then we will have two equations surface to it. So don't you feel it's a kind of a same kind of question that we had before, but those were six variables in two equation. Now this is a four variable and two equation. Now see, you have four variables, two equations. You need two equations more to solve the question. So pay attention to it. So again, the concern is this is wouldn't expected an actual distance be the same because that is generally available data. Plan and actual times and speed may definitely vary though. Okay, Ishan, I'll answer your thought after this particular concept is done for definitely, right? All right, so now the CMT4A. Now this is uh, if you get C as an answer too easily, then consider A and B. So this particular CMTs is something, as I've told you before also, that if you get C as an answer too easily, then consider A and B. Now, this is wherein I have asked you that, uh, you know, you need to master it, because at times when you feel that it is C, it's not at all, not necessarily that it will be C, right? So this is wherein I've requested you to, visit the website, register yourself, look at the lessons, and Ravi, yes, you can definitely get a lot of actual GMAT type of questions there as well, right? So in this particular slide, to talk more about the concept, the questions are pretty, they're as close to GMAT, but yes, again, not of considerably high level right now, because I'm more into talking to the concept approach and introduction. But Ravi, you can definitely, and others can definitely make up to the website to see a lot of those questions and the approach. And I'll definitely like if you guys can, capture those approach, please. So it says the condition with a ratio wins over the condition with a number. Now, see, my life is getting easier because I know what could be the answer. I just have to apply and just make sure that that is the answer or not. Rather than chasing what could be the answer, it is much better to know or prove that is that the answer. It's as simple as this. If you have to buy up a denim for yourself, the best denim that comes around from, from from any brands you need to know. You just need to know from where to get it. That it's it. Color differences, color variance is all up to your choices, but again, you should know, right? And right, so let's go with this particular tricky question, and I want everyone to try applying the logic through variable approach in this, please. uh, because you guys are already good into it, so you can solve it, but I don't want you to solve it. I'm just asking you to apply the variable approach logic into it, so that let's see how easy and comfortable you get with it through. So when John traveled from A to C through B, so now see, this is what GMAT is. John has traveled from A to B and B to C. Rather than writing that into a simpler format, they will always write in this particular way: when John traveled from A to C through B. So a particular person who rushed through just reading the question in one go will definitely miss out on that word called through B many a times. So when John traveled from A to C through B, so it's like A to B and B to C. Definitely, I'll explain the ratio versus the answer on the last slide. I'll definitely explain this into this slide as well, right? Okay, so he traveled from A to B at a constant speed of 50 kilometers per hour. So there's some distance of between A to B, and it is traveling at 50 kilometers per hour. Done. If the distance from A to B is one third the distance from B to C, now they have related the distance, right? So if the distance of A to B, suppose if it is taken as D1, then distance from B to C can be taken as B2, and D1 happens to be 1 over 3 times of D2. What average speed did he travel from A to C through B? You need to find the entire average speed of his journey. Okay, I'm not going ahead with the solution for at least 10 seconds, guys. Just put into your thoughts what can be done. Where can we start with the variable approach? Let's apply the variable approach. How many variable do we have? First of all, pick how many variable do we have in this question. So now see, A to B is one and B to C is another. A to B distance and B to C distance, D1 and D2, two variable, but D1 can be expressed in terms of D2. This is the actual catch in this particular question, right? So in this scenario, if we go ahead and talk about the variables first, A to B speed is taken to be V1, taken. Time is T1, distance is D1. D1 happens to be V1 times T1, and that is 50 T1. Now see, what we are trying to do here is we are modifying the question. So D1 happens to be 50 times T1 because we were given 50 kilometers per hour as a speed. Now let's go with B to C, and it's the same. Speed is V2, time is T2, and distance is D with a subscript of 2. D2 equals to 3 times of D1. So that happens to be 1 over 3 times. This is already been given. Now this is the change. You cannot always talk about 6 variables. You cannot always talk about 2 variables, right? 4 variables. You need to be very, very focused on it. I have just got 4 variables into this, not 6. T1, okay. D1, agreed. V2 and T2, because D2 is already expressed in terms of D1, so I don't need that variable. And V1 is already given to me, which is 50 kilometers per hour. I don't need that one also. So I'm been just left out with 4 variables. 2 equation still holds because that is in terms of D1 and 3D1. Now, the CMT4A tells me a strategy therein where it says that if you're one of the particular equation or a condition is in ratio and another is in number, in such cases, then the ratio wins over the number. This is the priority. The total distance from A to C through B is 200 kilometer. Now see, this is a number. John traveled from B to C at a constant speed of 150 kilometer per hour. B to C, this is a ratio. So in this particular scenario, I have in my back of mind that correct answer is B. So I'll be more focused in dealing with D. So now in this particular scenario, average is total distance over time. Let's talk about it quickly. Average speed from A to B. I find out the value of V1 equals to 50. So time taken here is D1 over 50. Time from B to C, that would be 3D1 over V2. D2 has already been converted as 3D1. So this is the basic format that we have applied. Distance from A to B, one-third distance from B to C. D1 is D2 times of 3, 1 over 3. So D2 happens to be 3D1. And then when you apply this, when you cancel out, you find the average speed, that is D1 plus D2. Now see, D1 plus 3D1, done. T1 plus T2, that happens to be T1 written in form of D1, T2 also written in form of D1. So now you need to find the value of V2. V2 equals to 150. That is something which you could put and your answer second is done. But if we go with the equation number 1, wherein it says that D1 plus D2 is 200, that is like 4 times D1 is 200, absolutely. So D1 happens to be 50. Yes, Sumit. And therein where you still cannot define the value of V2. You're absolutely correct in getting the distance of 50, but you cannot determine the unique value of V2 in this case, and D would be the correct answer. So this is actually, wherein there we catch what will be the answer and we proceed into the same direction. See, the solution remains same, the concept remains same, but the time you save in picking what could be the answer is the major crux of the variable approach. The only case is like, you need to master it. You need to actually see, because first we have seen about, uh, three variables in equation, then therein where we came with, six variables and two equation. Third question was more or less looking like it's a six variable because there are two things, A to B and B to C, but we didn't think about the fact that there could be a relation between the variables, or maybe some variable was already being catered with some information. So we need to focus on those things, right? So yes, you can make a note of it. It's like, you will get the links uh, into your emails. You can definitely visit the website. You can see all those variable approach. You can drop us an email talking about this. Let's talk about the work rates now. See, work rate and speed distance problems are almost same and similar. So it's not a very difficult topic. So we can definitely capitalize it in few minutes from now. It goes as same as what we have learned, or we have talked today. It's like speed equals to distance over time, speed into time equals to distance. So similarly, work rate, it's R, work done is W, time taken is T. So it's always an inverse relation between the rates. So it's always RT equals to W, or R equals to work done over time, that is equals to W over T. And again, the basic. So, to me, it looks like indeed the same. It's, RT equals to W. It's similar. It is looking to me as VT equals to D, and speed equals to distance over time. So, it's almost same. So we'll go very quick on this. So machine A produce 100 bolts in 5 hours. Obviously, 1 hour it will be able to produce 20 bolts, and then let it work for how many hours you want to, and we can definitely get over how many bolts do we require. Importance of units again plays an important role everywhere. First property of the work rate. So this is a kind of, you can take it as a revision, but again, yes, let's quickly solve this question, guys. A certain machine produces 50 units of item 1 per minute. If the machine works at a constant rate, what will be the daily production quantity of the machine? Per minute, 50 units. Daily production quantity of the machine is asked. Rate is not changed. What could be your answer? Come on, people, I don't want you to use any copy or a pen. It's simple calculations. So 50 units is okay. Shruti has already given answer is 72,000. So yes, that is it. I mean, like 50 times. It's a daily work. One day, Sadia has come up. The caliber has come. See, yes, 24 into 60. Yes, Sumit. 24 into 60 into 50. That is it. So I mean, see, such kind of questions can easily be demystified without even pen and a paper. Let's go ahead. I'll be definitely asking you the questions in the variable approach that I have. Second property again. Okay. If there are n number of machines, it gets multiplied by n. And this is wherein, if two people are working together, if two machines have been told to a particular, task and all. So work rate into time is work, then RT equals to W. N number of machines working, RT equals to W becomes an RT equals to W. Okay, fine. Let's shoot the next question. 10 seconds. So there are five machines with the same work rate for a job X that takes 25 hours for four of these machines to do together. Another machine is added so that five machines work on the job. How much time is saved by adding the one additional machine? 10 seconds. RT equals to W. Four machine takes 25 hours. Work rate is same. Shruti has already given the answer to us. Perfect. 5 hours. 5 times 5 is 25. 5 times 4 is 20. 5 hours will be saved. That is it. This is how, if I have to calculate. So that is what they have done. 4 times R into 25, that becomes 100 over 5, that becomes 20 hours. Perfect. Okay, let's go with another one. Working together and alone. So now see, in this situation, so A and B are working together. So A has certain rate to complete a work and B has a certain rate to complete the same amount of work. If they work together, in how many days will they complete? This is very basic format of, time and work. So how do they actually plan the question? So A comes in and A works for 3 days, and B joins in, and then before A moves, B has already left working for so much. So this is a kind of expression that we. So when two things are working alone, then working together, it is best solved by the reciprocal method. See, reciprocal is very simple. If I'm a single person working on a project, and if I'm taking 10 hours, if there would be two-person, then I'll take half of it. So it's not a direct proportion that if I go ahead and buy a chocolate for me for $10, and if I need two of those, then I have to pay 2 times 10, that is $20. It's a direct relation. When it comes to the work and time, it's always an inverse proportion, and then we need to understand if the number of people are getting less, the amount of time it would take will be more, and therein where what we say is, if A can complete a work in suppose P days or X days, then in one day it would be able to complete 1 over X amount of work. And this is why we called it as a reciprocal method. And once you do it, so next question is on the screen, and next 1, 2, and 3 seconds maybe. Okay, it's there. Let's see. So it takes 6 hours for machine A to produce 100 keys working alone, and it takes 4 hours for machine B to produce 100 keys working alone. Then how long does it take for both machines A and B working together to produce 100 keys? Now, before you solve, guys, I just need to tell you one thing. How do I look at this particular question? My answer should be less than 6 and 4, right? Though every option here is A, B, C, D, E, all the options are less than it. But again, I'm not looking even the options. I just know as per a basic concept that if my answer is somewhere between 4 and 6, then it would have been much better for me to go ahead and ask the B to complete the work, right? So this is wherein you go ahead with the logic. I've already came with one of the answers on the screen. People are still solving it. Let's solve it quickly together. All right. So 6 hours, 100 keys. Rate is 100 over 6 for A. Okay. Shruti has also given answer. Sadi has also given the answer to us. Okay. So we have for A, it would be 100 over 6. Sankalp has come up. So he has come up with 2.4. Good. And machine B is 100 over 4. What do you need to do? 100 is any which way is common. You're done. 1 over 6 plus 1 over 4. So that is T equals to, oh my God, Calumet has already written the complete solution onto it. Perfect. 100 over 100 over 6 plus 100 over 4. Good job. So that happens to be 2.4 hours. Okay. Inverse proportion. So let's try the another one. So it's an inverse proportion of work rate and time that I have already spoken about. So there's a question for you guys. Ravi has already taken 2.0, Pulkit 2.4. Okay. Champions go on to the another one. Machines A, B, and C can complete a task at all their respective constant rate in 2, 4, and 5 hours respectively. They have already used the word called respective constant rates. Okay. If machine ABC will complete the task when working together at their respective constant rates, what fraction of the total amount of work by machine ABC together? Sure. I'll slow down. I'm so sorry for it. And thank you for writing that. I'll definitely control. Thank you. Okay, so do you mean in going with the solution, I should slow down, or am I speaking very uh, fast? I mean, like, am I changing the slide so fast, or you can write it onto it? Okay, Shreyas has got the answer. Now 2.4. All right, so we'll go slow for this if machines with the solutions. Okay, fine, sure. That's my bad. I'm so sorry. All right, so if machine A, B, and C will complete the task, let's go with the solution for this. If work is constant, rate will increase with the decrease of time. So if time taken to complete the task increases, the work rate will decrease. This is what it says. We have three machines, which is A, B, and C. So machine A can complete the work in 2 hours, B can complete in 4 hours, and C can complete in 5 hours. So let's try to find, so this is their time ratio, that is 2:4:5. Now, if I go ahead and talk about the work ratio for them, it would be inversely proportional to the time, right? So work ratio happens to be 1/2 is to 1/4, and that happens to be 1/5. Now, how do you solve the ratios, which are a kind of more or less fractions? So what we do here is we take the LCM of the denominators. LCM of denominator 245 will be 20. So now try making 2 as 20. So I have to need to multiply this by 10. If I multiply anything to denominator, definitely I have to multiply it to the numerator. So my same goes for 4 into 5 and 5 into 4. So it happens to be 20, 20, 2, 4, 5. So ratio becomes 10:5:4. Now this is the work ratio. Question asks, what fraction of total amount of work by machine ABC together is the amount of work done by machine A alone? Machine A is doing how much? 10? Okay. And what is the total? 19. So how many of you say that answer should be A? It should be A, 10/19. It looks like to me a more as a report card that used to come during our high school. You got 10 out of 19. Okay, so is the answer A? Let's check it out. That's it. All right, let's go ahead. Anyone has a doubt? I can hold this even for a minute. That's not a problem. If you have a doubt to look at it, I mean, I should not name Shruti. Do check it once. Why B? 5 over 19 should be for B. They've been asking for A. That could be a mix up, but rest is okay. Let's go. Let's proceed. DS question. Now, this is something which you will solve by the variable approach, people, right? I want you to apply the variable approach now because it will be as same as what we have done for speed, distance, time, right? I'll go very slow. You think about only the variable approach and then try giving me the answers for it. So if it's a one machine, I'll have R. What if we don't have a constant rate? Okay, Sumit, I'll talk about that. Or you can write me that into an email at info@mathrevolution.com, and I'll get back to you in that particular question. If we don't have a constant rate, then we have to see. If we don't have a constant rate, then we need to find the equations to it. We need to equalize the work, right? So suppose if A takes 20 hours to complete or to say I'll say 20 hours to produce 500 pin. B takes 30 hours to produce 700 pins. So now see, number of entities and number of hours are different. So you need to actually come up to a place therein where you talk about just one pen. How much time do they take for one pen to produce? That is wherein you need to take it into, you need to convert that into a constant rate to solve the question. Because if you have a variable rate and a variable amount of work to be done, I then the answer in the DS would be E, but again for the PS it will be difficult. But you can write me that and I can get back to you on that in more detailed way. Okay, Sumit. All right, coming to this DS question, RTW as similar as VT equals to D and three variables, one equation. This is something which you have recently gone through. So it should not be difficult at all for, you know, every expert that is there with me today. So now let's put this to the question. I seriously want you to apply only the variable approach. Please try applying it quickly. Certain machine makes box at a constant rate. How many minutes will it take to machine to make 500 box? C. It takes the machine 6 minutes to make 20 boxes. It takes machine 1.5 minutes to make 5 boxes. I'm a habitual. I'll directly pick, you know. But can I solve it by A? Can I do it by just D? Because there is a catch here. Yeah, people have started getting the answer. Very good. Good. Pull kid. Check once, please. We know we have got, you know, three variables. We've got one equation. We need two more equations. Those two can be sufficed from condition 1 and 2. But if I'm not wrong, 1.5 times 4 is 6. 5 times 4 is 20. Condition 1 equals to condition 2 gives me the same. So D would be my answer. And that is also one of the approach that if condition 1 equals to condition 2, then D would be the answer. So let's try applying this. We need to find the value of T. RT equals to 500. Answer is D. Now see, we have RT equals to 500 already here, which is the equation. So D is the most probable answer for this. We have two variables, which is R and T. RT equals to W. And Absolutely. So we have only two variables RT. We have equation RT equals to 500. We already have one equation with us. We just need one more equation. So now one equation comes out from where? It can come from both separately. When it comes from the both separately, definitely A and B both are sufficient, self-sufficient to give me the answer, and therein where my answer becomes T. And you guys have got it. That is wherein, we make it as sufficient to, unique answer sufficient to. So when you make choose D as more likely answer, when you have this into your mind, just go with condition one, check it quickly. Condition two, check it quickly to make sure D. If it's not D, then you have to go for a C and see. This is wherein I was talking about. This is the line which I was just explaining you guys. The value of condition one equals to condition of two. If this happens, then it's the most likely answer is D. So we have such almost 6 to 7 types of tips. And Sumit, A and B both are the same. If you see, 6 minutes 20 boxes means 1.5 minutes 5 boxes. They both are the same kind of equation. 620, yes, you can find the value from there, but you can even find the value from 1.5 minutes to 5 boxes. So this is what it happens. If you get the answer as A, you need to do check for B also, because even D is there in the picture to be an answer, right? You're absolutely right, Sumit. Just the concern is both are same. So you need to check for the B also. All right. Work rate of two machine. It's again simple. R1 T1 W1, R2 T2 W2, 6 variables, 2 equations. Let's have a question. Let's have a question. Machine A and B have produced toys at their constant rates, respectively. Okay, it's there on the screen now. In how many hours does machine A produce the total number of toys? Machine A produce a total number of toys. Uh, Nico, we just applied the formula because we have prepared those, as a notes for the students, right? So what happens is, like, you have been learning it, it's easy, you can definitely relate it. But anyone who's been looking at it first time maybe may not able to relate where does that value come from. So what happens at our end, like being a trainer and content developers, our team always have to look into it, to relate it, where does it come from. We are not asking you to apply such complex formulas, even if it is a simple question, no. But for everyone, it should, gives the sufficient information. So that is where we have applied it. Okay, people have already coming up with the answers. They say B. Okay, so in this scenario, these steps we follow, we have a find value of T1. So we have 6 variables because we have two machines. We have 2 equations. We need 4 more equations. Logically, the answer should be E. So we directly take condition number 1 and condition number 2 together. Condition number 1 says machine B produces 300 toys in 3 hours. So the rate is 100. Condition 2 says the total number of toys that machine A must produce is 1200. So R1 times T1, that is a W1 work that is done, is 1200. But the concern again here is, where is T1? Because they are asking in how many hours does machine A produce it. So you need the rate and work. So T1 values is still undetermined. So this goes as E. Right. Okay. Yeah, that was the last question. All right. So I'm obliged and I'm blessed that there are a lot of people who have been a part of today's webinar. We often lack on time, so we talk very less, and because such kind of approaches are very good for demystifying the exams like GMAT, definitely. So I recommend you, I request you that go to the website, try catching up with the videos, get into it. At times it looks very easy, when you start applying in the initial phases. Once you get into deep of it, I'm telling it to you, you will like it, because you guys can play around with this. I'm telling it to you. The way you have answered today so quick, I found to be into a well community today, because I like such kind of presentations, and I like such kind of interaction. I was not here to solve the questions. I was not here to teach you math. You guys are already good at it. I was just trying to bridge up the gaps which can make a score from Q49 to 47 maybe, or 47 to 45 maybe. So I wish you best luck for all the coming preparations that you have, right? And keep doing best. Prepare yourself, take a proper care of your health, have a good sleeping pattern, enjoy also, because that is also required, and done, right? So yeah, I would take a leave now, and let's enjoy. Bye bye. We will definitely design some more. We are coming up with more. So be connected to us, and you can write us back on the email. We'll love to answer you all the theories. Thank you so much. And thank you so much, GMAT Club, for your support. I mean, this would have been impossible without your support. So thank you so much for that. And I wish everyone have a good time ahead. Thank you so much for today. Thank you.